In this work, we learn semantic scene graphs from 3D reconstructions. The goal is to identify the objects in a scene, as well as their relationships within a given context. Given a 3D scan of an indoor scene, our method's input is the class-agnostic instance segmentation. A semantic scene graph consists of nodes, the objects in a scene, which are identified by its semantic labels and properties, and the relationships between the nodes. It's important to note that those connections are of semantic nature. They either represent support, proximity, or comparative relationships. Learning 3D semantic scene graphs means to generate such a graph, here on the right, from a 3D reconstruction, here on the left. For this, our method extracts the point cloud for each object segment, as well as the points of the joint bounding box. These are processed with two different point networks to produce point features for the nodes and relationship features for the edges. These features are then further processed with a GCN to predict the 3D scene graph with node and edge labels. Our network produces semantic scene graphs for a variety of scenes. It can handle a large number of semantic classes and is able to identify multiple relationships per edge, as well as non-existing connections, so-called nones. We show its application in a cross-domain retrieval task, where graphs serve as an intermediate representation. We introduce so-called 2D to 3D retrieval, where the task is to find the matching scene from a pool of 3D scans, given only a single image of a changing scene. In the context of this work, we introduce 3D SSG, a large-scale dataset of semantically rich scene graphs built upon FreeRScan. It features 1,482 scans of 478 scenes. Our graphs have approximately 48,000 nodes. The nodes are connected via more than 500,000 edges. To summarize, the contribution of this work is threefold. We introduce 3D SSG, a large-scale semantic scene graph dataset. We propose the first learned method that predicts a semantic scene graph from a 3D point cloud. And we show how graphs can be used in a cross-domain retrieval task to bridge the domain gap between 2D and 3D, opening doors for new applications such as text and 3D retrieval or visual questioning and answering. Thanks for watching.